I wanted to make a video that talks about the concepts of frequency, angular frequency, and the period. So let's just start by reviewing what frequency is in general, and we'll call this letter F. Frequency in words is the number of cycles or periods, they're synonymous, per second. So for example, if I were to draw a displacement versus time graph, let's say I have a sine wave, that's one period, right? It goes up, it goes down, and then it returns to its initial position. It's another period. It's a little bit longer because I want to show 3 periods. That's 3 periods. So that's 1 period, 2 periods, 3 periods. And I'll say that this amount of time, remember this was time, is 1 second. So within that 1 second, I have 3 periods, which means that my frequency is 3 cycles per second, which we typically write as 3 hertz. And cycles is a dimensionless quantity. So really, if you look at the units of hertz, this is 3 1/2. But all 3 are the same. My dog's mad in the background. So 3 hertz. Now, in regards to a period is more so related to time. A period is how long does it take to complete 1 cycle. So again, if I were to draw that again, one, that's 2, it's 3. So that this whole thing is 1 second for 3 periods. How long would it be for 1 period? Well, if they're exactly the same, and again, my drawing is not to scale because I suck at drawing, but the question is, how long are each of these? Well, if they're each equal and the total amount of time is 1 second, that means that each cycle takes a third of a second, right? 0.33, repeating seconds. So if I were to have a mass that's moving back and forth, it would take 0.33 seconds to go from its initial point to its positive amplitude, go to its negative amplitude, and then back to 0. That will take a third of a second for this example. Now, we did that by noting that there is 3 periods in 1 second, and we did division. We took 1 second and divided it by the number of periods. If we look at our frequency, we see it's 3 hertz. There's a relationship there. The relationship is going to be that if I take the reciprocal of the frequency, that'll give me time. So if another way of thinking about this is that the period, they're called TP, the time of the period, that is equal to 1/f, which is equal to 1/3 hertz. And we know that hertz is in units of cycles per second, or 1/second. 1/3 cycles per second. Since I'm dividing by this, not only do I do 1/3 to give me 0.3, but the units are going to flip also. So this ends up being 0.33 seconds cycle. And that's what the period is. It's how long does it take for one cycle to happen. While the frequency is how many cycles occur in 1 second. They're somewhat opposites of each other. Okay, so far? I know you can't answer me, but I want you to think to yourself, yeah, I get this. And if you don't, rewind it and watch it one more time. The final thing I want to talk about is angular frequency, which we know is omega. And that's what we see in our class a lot, because we have the sine of omega times t. So the relationship between these guys is that if I were to draw, let's say, one period, and I were to relate this to the unit circle, and this is going to be sine t, is this red graph, it's a sine function. When t is equal to 0, we are here. And the value of our function is 0. That is, related to the angle on the unit circle. So this is related to angle on the unit circle. So at t equals 0, that is corresponding to an angle of 0. And what is sine of that angle? Well, sine is vertical distance from the axis, and at this location, there is no vertical distance. It is just, that's 0. Now, as I travel along the unit circle, I'm increasing in height, right? So like if I go to here, my height's pretty big. If I go to here, my height's getting bigger. If I go to here, it's even bigger. And then I'm at the top here, and that is a maximum value of 1 for the unit circle. That's the radius of the unit circle. That is why over here, we are increasing in our sine function until we hit a maximum value of 1. This point here corresponds to 90 degrees, if we were to think of it as an angle. And then, if we continue going around the unit circle, and I'm going down, we see that our height's decreasing. And that's what we have in this region on the sine graph. I started at the max now at 90 degrees. And once I continue, I am decreasing until I hit 0. And that is going to be at 180 degrees. Which is this point right there. Now, if I keep going past 180 degrees, now I still grow in height, but now I'm negative. So I go to this point, my height is growing, my y-axis position, but it's getting more negative until it gets to -1. Well, that's the same thing we have here. The height is growing, it's becoming more negative until it gets to a value of -1, which is at 270 degrees. And then lastly, my height is becoming more positive and approaching 0. And we see that here. It's growing, and it's ending up there, and it's 360 degrees. And that is a full period. We went around the unit circle. So 1 period is equivalent to 360 degrees, but we don't use degrees. We typically use radians, which means 2 pi radians. So every time I do a period, that means I'm going around the unit circle once. I'm going to write that down so we see it. Every time complete a period, go around unit circle once. So if I were to relate this to a frequency now, if I were to relate this to a frequency, let's say I said that F was 3 hertz, like we had before, in that 1 second, I had 3 periods. So I had 1, 2, 3 periods. And this was in 1 second. So this is 3 periods per second, or 3 cycles per second. 3 hertz. Now the question is, how many times do I go around the unit circle? Well, we already said that if I go around once, that's a period, right? I went from 0 to 90 to 180 to 270 to 360 in that one period. If I were to do 3 periods in that second, how many times did I go around the circle? 3, right? I went around 3 times. So went around the unit circle 3 times. So from those 3 periods, how many radians did I do? Well, if you went around once, you did 2 pi. You went around again, it's another 2 pi. And you're around a third time, it's another 2 pi. So that ends up being 6 pi. So in this case, we did 6 pi radians per second for this specific problem, because I have 3 periods in a second. That means I went around the circle 3 times. And that's where this relationship comes from, where we say that the angular frequency is equal to 2 pi times f. So if I know the frequency is 3 hertz, that means I'm doing 3 periods in a second. That means I'm going around the unit circle 3 times. And that means if I multiply by 2 pi, I find out how many radians I'm going around in that same amount of time. So instead of 3 periods per second, we say it's 6 pi radians per second. So if I were to just summarize this, omega n is related to Fn, or natural frequency any f. So I'll just say any omega and any f. Ignore the natural frequency. They're related by 2 pi. So omega is 2 pi f. This is angular frequency. This is just a frequency. And how I'm going to get period, I take the reciprocal of f. I cannot jump directly from omega to t because I need to include a factor of 2 pi to do that. So if I wanted to just go ahead and jump directly from omega to t, if we know omega is 2 pi f, and I know f is the reciprocal of the period, that means we get 2 pi t. So that means that Tp is 2 pi over omega. If you wanted to go that route, you don't have to. I just think about it as I want to find the frequency to know how many cycles per second there are in f in just hertz. And then I will inverse that. So just to summarize, this is radians per second. This is hertz, which is equal to 1 over seconds, or cycles per second. And this is period, which is just seconds. Okay, I hope this was helpful. Let me know if you have any questions.